Hi friends, welcome to World Explorer. If you like, comment and subscribe our channel. Today's topic is PERT, Program Evaluation and Review Technique. It is a statistical tool which is used in a project management. It helps to analyze and represent the tasks, usually used along with CPM, that is called critical path method. There are advantages for this. Advantages are it identifies the critical path, early start, late start and slack. Decision making can be done by organizing the data in diagram. Schedule, organize and coordinate the tasks. Now let's take an example of project. Here if you can see, if it is a very complex project, then we have to divide that complex project into small steps like 1, 2, 3, 4, 5, 6, 7, 8. And ultimately 8th is the final step. This PERT is usually represented by the arrows and the nodes, and this is how it shows. Whenever a task is finished, it is to be followed by some another task or preceded by some another task. So the previous task is called as predecessor and the following task is called as successor. So the steps of PERT is, first thing is analyze the tasks of the given project, that is the time needed to complete each task, minimum time needed to complete the project, and there is uncertainty. If we don't know the exact details, that is the precise details and the duration of activities, it is very difficult to do the PERT. Time is a major factor but not the cost in PERT. Here in the diagram we have shown that it is represented by arrows and the nodes. Arrows represent the activities or the work necessary to reach the event, and nodes completed phase of the total project, which is represented by the circle. So it is called as arrow and node diagram. Next thing is, in PERT we have three different times, the CPM method. Here we can see optimistic time, expected time and the pessimistic time. What is optimistic time? Optimistic time is nothing but the time which we can foresee and we can complete the project in a fixed point of time, that is called as optimistic time. Next thing is pessimistic time. Pessimistic time is if there is any problems which arise during the project may get delayed, it is called as pessimistic time. Expected time is the time, this lies in between the range of optimistic and pessimistic time. These details we will see later. See about the events in the PERT. PERT event start to completion, that is called as PERT event. It consumes no time and no resources. It occurs only after all the activities leading to the event have been completed. Predecessor event, this is immediately preceding some event without any other events intervening, and it can have multiple predecessor events, can be predecessor of the multiple events. And the next thing is successor event. This immediately follows some event without any other events intervene, can have multiple successors and can be successor of the multiple events. Again the PERT activity can be divided into sub-activities, and again sub-activities can be divided into the sub-activities like A1, A1.1, A1.2, etc. Now we have seen the times are three different times, like optimistic time, that is the least amount of time which may be needed. Pessimistic time, because of some problem there is a delay in the project, for example right now corona is causing so many delay in the projects, it is called as pessimistic time. And M is the most likely time, it is the best estimate time, assume no problems there. So E is expected time, that is the time required to accomplish the activity. So best estimate time is the path assuming everything proceeds the normal. Here best estimated time can be calculated with the help of formula 0 plus 4m plus p divided by 6. It is not 0, it's O. O is nothing but optimistic time, M is most likely time, P is pessimistic time. And again it can be shown as time expected is equal to sigma I is equal to 1 to n TEI. And there is a standard deviation time or called variance. It is equal to P minus O by 6, that is pessimistic time minus optimistic time divided by 6, or sigma TE is equal to square root of sigma 1 I is equal to 1 to n standard deviation TEI square. This is how we can calculate the standard deviation time. Now let us see PERT management tools. First thing is float or slack. Float or slack, here we can see positive slack means ahead of the schedule, negative slack is behind the schedule, zero slack is on the schedule. Next thing is the critical path. The longest possible continuous pathway is from start to stop, that is initial event to the terminal event. So it is the total calendar time required for the project is called as critical path. If there is any time delay, there is a delay in reaching the terminal event. Critical activity, there is total float is equal to 0. Critical activity may not be on critical path since path may not be the longest. Next is the lead time. The time by predecessor event to be completed. It allows sufficient time for activities that elapse before as specific PERT event reaches the completion. The next is lag time. It is the earliest time by which successor event can follow a specific event. Fast tracking, performing more critical activities in parallel. Crashing critical path, shortening duration of the critical paths. So this is the advantage in the PERT. We can even shorten the duration of the event or project. Implementation, schedule a project, determine the tasks in order of completion. Order, easy. Sometimes it is easy. For example, building a house, we have all the steps in hand. Sometimes it is very difficult because there may be two activities needed which can be done at the same time, and because of less resources it may become very difficult for us, or we can choose only one activity out of the two activities because of less resources, so it may be difficult for us to plan. So the time estimates are normal or non-rusted time, or sometimes we can decrease the time estimate it because of additional cost or to decrease the quality. Now let us see an example. If optimistic time, most likely time, pessimistic time in days is given in a critical pathway as below, OMP, like the tasks of E, F, G, H, I, you can see OMP is optimistic time 8 days, mean time 10 days, most expected time is 10 days, and pessimistic time is 14 days. So what is the expected completion of project in days is? So this is how the formula is, we have seen already. Time expected is equal to optimistic time plus most expected time into 4 plus time pessimistic divided by 6. So we have to calculate for each event. We can see here E to F it takes 10.33 days, F to G it takes 8.16 days, G to H it takes 7.16 days in the same manner, and at the end we have to summation of all the days, which results in 37.81 days. The next question may be, for a construction project, mean is 200 days, standard deviation is 6.1 days for completion of project. Assume a normal distribution and use standard normal deviate of Z is equal to 1.64 at the rate in 95% confidence interval. Maximum time required for completion of project in days is equal to, we know that mean is already 200 days, standard deviation is 6.1 days, and Z score is 1.64 in the 95% of confidence interval. It is assuming a normal probability curve. So we can see maximum time required to complete the project is Z is equal to X minus mu by standard deviation. If we substitute the values in this, we can get X is equal to 210 days. To summarize the project, PERT is program evaluation and review technique, where we can see the complex project is divided into series of activities. It may be sequentially or parallel events. It is collection is modeled as a network. We can see in the times also displayed on the project, like optimistic time, pessimistic time, most probable time, and we can see activity of A is leading to is the predecessor of B and C event, and B and C are the successor events of the A, and which is even followed by the successor events of F, D, E, etc. And usually it is represented in arrow and node diagram, and even there are subtasks for this. But before reaching the final project, we need to complete all the predecessor events, then only we will reach the final project completion. If there is any delay in between in this network diagram, there is a delay to reach the final project. So this is again In only difference between PERT is and CPM method is, in CPM method we see there is a fixed time because it is easy, but in PERT we have the 3 times, that is optimistic time, most probable time and pessimistic time. So it has a great potential to manage our time or to decrease the time of project, and the cost also can be maintained. But what will happen is, when we are decreasing the time, there may be a decrease in quality, or if you want to maintain the quality, the cost may increase. The steps is identify the specific activities and milestones, proper sequence of events, network diagram, estimate the time for each activity, determine critical path, update PERT chart as chart progresses. Expected time is equal to optimistic time plus 4 most probable time plus P divided by 6. So optimistic time is the shortest time which is needed, most likely time is highest probability, pessimistic time is the longest time. If you like our video, subscribe to our channel.